I welcome you all for this lecture series on 4G and 5G communication networks. In this lecture number 16, we will briefly discuss about 5G architecture. First of all, let me briefly explain about what is the necessity of studying this 5G architecture, or what is the necessity of understanding the 5G architecture. And this understanding 5G architecture is essential because it lays the foundation for the next generation of wireless communication, significantly impacting how we connect and interact with the technology. With its capabilities for higher data speeds, lower latency, and the ability to support a massive number of devices, 5G will revolutionize industries ranging from healthcare to transportation. Knowing how 5G architecture functions helps stakeholders, including businesses, developers, and policymakers, in general, its potential for innovation, improve user experiences, and implement efficient solutions tailored to modern needs. As the world becomes increasingly interconnected, grasping the details of 5G architecture is vital for adopting to and thriving in a rapidly evolving technologies landscape. Next, we'll see the overview of 5G architecture. First, these are all the main points we are going to discuss in the 5G architecture overview. The first one is the user equipment that we are calling it as UE. User equipment refers to the devices used by end users to access the 5G networks. This includes smartphones, Internet of Things, that is IoT devices, and various sensors. These devices are essential for facilitating communication and enabling a range of applications from everyday mobile usage to smart city functionalities. And the next one is the radio access network. This we are calling it as RAN. This RAN is a critical component of 5G architecture that connects user equipment to the core network. It utilizes advanced technologies such as massive MIMO, that is multiple input and multiple output, and beamforming that is MIMO and beamforming to enhance the signal quality and increase data capacity. These technologies allow for efficient use of the radio spectrum, supporting a higher number of simultaneous connections. Next one is the core network, that is 5GC. The core network, often referred to as 5GC, 5G core. It is responsible for managing data routing, mobility, and overall connectivity within the 5G ecosystem. It serves as the backbone of the network. One more time, I'll tell you this 5G core network acts as the backbone of the network, ensuring seamless communication between different components and handling essential functions like user authentication, session management, and data transfer. Next one is the next network slicing. Network slicing is the transformative feature of 5G that allows for the creation of virtual networks tailored to specific applications and services. This is the main advantage of using 5G. It allows the creation of virtual networks tailored to specific applications and services. Each slice can be optimized for distinct use cases such as IoT applications or enhanced broadband, and enabling more efficient resource allocation and management within the network. Next, multi-access edge computing. This we are calling it as MEC. Multi-access edge computing significantly reduces latency by processing data closer to user at the edge of the network. This allows the this allows for quicker responses and real-time data processing, which is crucial for applications such as autonomous driving, gaming, and other latency-sensitive services. Next one is the standalone, that we are calling it as SA versus non-standalone, NSA. In the context of 5G deployment, standalone, that is SA, and non-standalone, NSA, refer to two different network configurations. SA represents a full 5G network that operates independently of previous generations, that is 3G, 4G, 4G, etc. While non-standalone NSA relies on existing 4G LTE infrastructure to support 5G services, allowing for a smoother transition to the newer technology. This is the function of SA and NSA. Next one is the cloud native infrastructure. What is the function of cloud native infrastructure? It refers to the architectural design of 5G network that leverages microservices for scalability and flexibility. This approach enables the rapid deployment and management of applications and services, allowing for dynamic resource allocation and the ability to quickly adapt to changing the network demands. So this is the function of the cloud native infrastructure. So this diagram is the overall architecture of, that is 5G architecture, consists of local server, central server, 5G macro, and 5G smart cell and other components. We'll see one by one. First, we'll see the local server. This local server, we are calling it as the edge computing, another name we are calling it as the multi-access edge computing, that is MEC. Before going into this, what is the function of local server? The local server edge computing, often referred to in the context of edge computing, or strategically positioned at the edge of the network close to users. This placement typically occurs at locations like cell towers, allowing for quicker access to data and services. By bringing computing resources closer to where data is generated and consumed, local servers help enhance the overall efficiency of network operations. Next, MEC, multi access edge computing. This MEC plays a crucial role in modern networks by processing data locally. This local processing significantly reduces latency, which is the delay before a transfer of data begins following an instruction. By enabling real time applications such as autonomous, I have told you many times, autonomous driving and virtual reality, this multi access edge computing MEC ensures that user experience minimal delays and more responsive interactions with the technology. And so what is the advantages of that is MEC, multi-access edge computing? One of the key advantage of multi-access edge computing is that it minimizes the need to send data back and forth to distant central servers. This reduction in data travel not only speeds up responses times but also alleviates the bandwidth load on the core networks. As a result, applications can operate more efficiently, providing users with a smoother and more immediate experiences. Next, central server. So this is what about this local server. Next, we'll briefly discuss about this central server. The central server, that we are calling it as the cloud core network. This 5G core network 5GC serves as the central server and the 5G architecture, and orchestrating the various elements of the network. It plays a vital role in connecting local servers and ensuring the data flows smoothly across the entire network. By acting as the hub of 5G ecosystem, the 5GC is essential for maintaining communication and operation efficiency among all components. And the role of central server is it manages the global tasks such as user authentication, data routing, mobility management, and security. And the advantages of the central servers, one significant advantage of having central server like 5GG GC is their scalability. which allows them to accommodate increasing global traffic and data storage. As the number of connected devices continues to rise, the 5GC can expand its capabilities to handle this demand. Furthermore, central servers facilitate complex backend operations such as processing and analyzing large data sets. By interacting with the local servers, the 5GC ensures efficient data management, balancing workloads between the central and the local systems to optimize performance and reduce latency for end users. Next, the relationship between local versus central interactions. The 5G architecture, the interaction between local and central servers operates on a hybrid model. So we are calling it as the hybrid model that optimizes performances and efficiency. Local servers are strategically positioned at the end of the network to handle real-time latency sensitive tasks such as processing data from autonomous vehicles or delivering instant responses for virtual reality applications. By processing information close to the source, these local servers minimizes delays and ensures the seamless user experiences. In contrast, central servers such as 5G core network manage large scale and global data processing, handling tasks that require significant computational power and data storage. This is the main advantage. The centralization allows for efficient user authentication, data routing, and comprehensive security measures across the network. Together, this hybrid model enables the 5G ecosystem to deliver high performance services while ensuring the real time application functions smoothly and efficiently, balancing the load between local and central resources. Next, 5G macro cells. This 5G macro cells are large, high power base stations designed to provide extensive coverage across various geographical areas, including urban, suburban, and rural regions. These macro cells are strategically positioned to ensure that they can transmit signals over significant distances, making them essential for establishing a robust 5G network. Their ability to cover wide areas allow them to serve a large population, ensuring that users have access to high-speed connectivity no matter where they are located. And the major role of the 5G macro cells are the macro cells serves as the backbone of the 5G network, providing wide coverage and supporting a number of users. And the key technology used in this 5G macro cells, one of the key technologies employed by 5G macro cell is MIMO, that is multiple input, multiple output. This innovative technology enhances data capacity by utilizing multiple antennas at both the transmitter and receiver ends. This is the main advantages of using MIMO, allowing for simultaneous connection to multiple users. With massive MIMO, macro cells can significantly increase the amount of data transmitted over the network, providing faster speeds and improving overall network efficiency. This capability is essential for supporting the growing number of connected devices and the high data demands associated with modern applications. Next, 5G smart cells, that we are calling it as the small cells. The 5G small cells, so also known as small cells, are small, low power base stations that are deployed in a dense manner within the specific areas, here, such as stadiums, shopping malls, and urban centers. Unlike traditional macro cells that covers wide areas, this what it will do is this smart cells are designed to provide localized coverage, enhancing network performances in places where many users congregate. This their impact, compact size and low power requirements allow them to be installed in various environments, making them an integral part of 5G infrastructure. This is the function of a small cell. And the role is the small cells focus on improving the network performance in areas with high traffic and help offload data from macro cells. And the main advantages of using the 5G smart cells, or one of the significant advantage of 5G smart cells, is their ability to enhance capacity and speed in the densely populated urban environment. That is the main advantage of using this. In areas with a high concentration of users, such as city centers or event venues, smart cells help maintain high quality connections by providing localized services. This results in improved user experiences, allowing for seamless streaming, faster downloads, and more reliable connections even in crowded situations. This is also another advantage. By strategically placing smart cells throughout urban landscapes, network operations can ensure that they meet the growing demands for mobile data and connectivity. Next, coming to the conclusion, the 5G network is designed to effectively handle real time, latency sensitive tasks by utilizing local services positioned close to users, ensuring quick responses and improved user experiences. Central servers manage large scale global operations, including data routing, security, and user authentication, providing a cohesive framework for connectivity. Macro cells deliver broadband coverage and support a significant number of users through advanced technologies like massive MIMO, which enhances data capacity. Meanwhile, smart cells focus on improving network performance in densely populated areas with high data traffic, as I've already said, allowing for the maximum communication. The strategic combination of local and central servers, along with macro and smart cells, ensures that the 5G network is efficient, scalable, and capable of delivering high performance connectivity to meet the demands of modern users. So, understanding the so from these above discussions, the understanding the 5G architecture is essential as it provides insights into how modern telecommunication networks are designed to meet the increasing demand for high-speed connectivity and real-time applications. This architecture, understanding of the architecture highlights the role of local and central servers as well as macro and smart cells in delivering efficient and scalable network performances. By learning about 5G architecture, we can appreciate the technological advancement that enable innovation such as IoT, autonomous driving, enhanced mobile experiences. Ultimately, this knowledge equips us to better navigate and leverage the opportunities presented by next generation communication networks, that is 6G. Hope everyone understand about this 5G architecture. The remaining things we'll discuss in the next lecture. Thank you.